Hi guys, welcome to Piece of Code and welcome to this episode number 21 of Java OCA crash course series, right? And in this episode we are going to discuss about Java arrays, right? We are going to see how you can create an array, how to use an array, sorting, searching, Varargs and multidimensional arrays. So we are going to complete everything from an exam perspective and also from the programming perspective of Java, right? We're going to cover a lot of stuff. So let us move on. So let us understand the basic structure of an array, right? How do you create an array in Java? So first of all, you need to specify the type of an array, right? In this case, this is an integer array which will contain numbers, right? So I have specified int over here, which is the type of the array. Then this is the array symbol, which is a pair of rectangular brackets, right? And as this is a single dimensional array, it is one pair. If you create multi-dimensional arrays, then you have to specify two pairs and n number of brackets for n dimensional arrays, right? Then you have the variable name over here. Then you have to use the new keyword, and remember, this is one way of creating an array, but this is the basic structure in how we create an array. New keyword and then int, which is the data type. And here you specify the size of the array, right? If an array is going to contain 5 elements, you just specify 5. If it is going to contain 3 elements, you specify 3, right? So this should be clear enough. Let us move on. Now let us talk about an uninitialized array. It means that when you create an array using this thing. So currently you are saying that, okay, create an array of size 3, but yes, Java is going to create an array for you, but what will be the initial value of those elements in your array, right? So if you take a look at this, the initial value will be the default value of that particular data type for each element in the array, right? We created an array of 3 elements, right? And basically it will create 3 blocks. It will allocate 3 sizes or 3 blocks for that particular array, and each element will be the default value, which is 0 in this case. But you can obviously change it to the element of your liking when you want to manipulate the array. But remember, the default is basically 0 for integers, and if you're going to talk about character arrays, it is a white space. And for different data types the default value varies, right? But the thing is, if you create an empty array, it by default it initializes the elements to the default values, right? Now this is an example of initialized array. This is just what you did is just you replaced these zeros with this stuff like 42, 55 and 99. Now you can do this with the use of indexes, and also you can loop through the array and change it all at once. Now what is indexes? Basically, each element in the array that you see over here is associated with an index number. Like we saw in case of strings, right? Each character in a string is associated with an index. In this case, the index value starts from 0 and goes till n-1, where n is the size of the array. In this case, n is equals to 3, so size is 3, so it means that the last index will be 2. And if you want to get an element at a particular index, for example this element, then you just specify the index number and you will get the element. Alright, we are going to see a lot of examples, so don't worry about it. So but this is how an array is generally structured. You have elements and then you have their particular index values, right? And arrays are just random access, right? You just go there and pick the index and just directly access that element. So that's why it is much faster when you are actually accessing the element as compared to other data structures. So let us see some examples now. I hope you understood how the array is structured in Java. Let us go to Eclipse and let me just create a new package over here, and I'm just going to name this package as arrays, and let us create the first class and let us name it as arrays 1D. We cannot use numbers, right? 1D. So first of all, we're going to talk about 1D arrays, so let us do that. Now creating an array of primitives, as we have discussed, it is pretty easy. let us first talk about primitive arrays, and then we're going to talk about reference variables, how you can create reference type arrays. So int numbers equals to new int 3. Cool stuff. That's how you simply create an array. So it should be pretty easy to understand right now. But as you know that by default the elements in this particular array will be associated with the default values because we haven't changed anything in this array. But another way of creating an array is to just give the elements directly while creating the array, and that kind of array is known as an anonymous array. Let us try that out. So let's say int numbers 2, right? And this is another way of creating the array. You can either specify the brackets at the end like this, or you can also specify the brackets like this. And why I'm using both of these types of array creation, because basically in the exam they will try to trick you by placing the brackets here and there. Like they can give you a question where they have placed the brackets here and they will give a option as compilation error, right? Which is not true, because this is a valid way of creating an array. So numbers 2 equals to new int, right? And instead of just giving the size over here, you just give a pair of curly brackets over here and just specify the elements, which is for example 40, 50 and 60. So now what will happen, instead of containing all zeros as default values, this array will contain what? 40, 50 and 60. So that's how it will be working out. Now there is another way of creating this same kind of array but with less code. Let us try that out. Int numbers 3 equals to, instead of using the new int or new data type, you just specify a pair of curly brackets over here and just say 1, 2, 3. Pretty easy to do. Instead of writing all this thing, you can just do this thing. Why am I showing you a lot of different ways of creating arrays? Because one is enough for you as a programmer perspective, but you should know all the types so that you will be able to handle all the questions in the exam. You don't want to go into the exam and there is an option on the exam which says compilation error, but in that case it is not a compilation error, right? So the exam may try to trick you in different types of creating the arrays and different types of stuff. Alright, now let us talk about multiple arrays in declarations. Now in this case we have created an array, right? But the thing is, you can practically declare an array first. For example, we can do this thing, right? Int x and y equals to 10, which is perfectly normal for variables, right? The same is true for arrays also. You can declare arrays like this and then later on you can just provide the size. That is known as declaration, right? Let us see how you can declare multiple arrays at once in one line, which is also very, very important in case of an exam's perspective. We can do this thing, int, then a pair of brackets. I can just say IDs and types. Now, what type of reference variables do you think the following code creates? Try to answer the question. Now, this is the tricky question in this case, but what do you think happens? The correct answer is two variables of type integer arrays. So it will create two variables, IDs and types, of int arrays, right? This is an integer array. Now this seems logical enough. Why? Because if you see over here, when you specify the pair of brackets and then you specify the variable name, then basically this variable becomes an array. So if we specify the bracket first and then I specify an ID, so that is an array, and then I specify types, so this is also an array. That's how it means. Let us see another example and this will be clear for you. Int ID1 and then let us say type 1. This is also true, there is no compilation error, because I have already told you, you can either use the bracket before the variable name or after the variable name. It makes no sense to use only one way of creating the arrays. They can give you n number of ways in which you can create the array and there will be multiple compilation errors. But you should know these two ways only. Now what do you think is the answer of this particular question? how many reference variables are created and what type of variables are being created over here. Now the thing is, we just changed the bracket location, but it also changed the behavior. How did it change the behavior? This time we get one variable of type int array, which is this one, and another variable we get of just a primitive variable, an integer variable, which is type 1. Why this thing happens? Because if you look at it closely, right, with this particular expression, this particular array declaration is over, right? When we end it with the brackets, it just means that I have created this single array with a one dimension array. So there is no more, place where you can create another array with a comma. Any other thing that you create after that will be treated as a variable. Alright guys, now let us see how we can create an array with reference variables. So here we go. So we can just see this thing. So string bugs, for example, equals to, let's see some bugs over here, not the actual computer bugs, it's insects. So cricket, not the game but the bugs, beetle, and then we have ladybug, right? Now what do you think is happening over here? If we do this thing and let's say alias equals to bugs, right, and let's see this thing, let's say bugs dot equals alias, and here if we do sysout bugs dot toString, right, and what do you think that this will return? In this case this will return true, and this will return a weird output. Let us see the output. Okay, let us just run this code now, right? So this is so this is nothing but this is kind of the hash code of the particular class, and this returns true. Now let us understand why this thing happens. So we can call the equals method because an array is an object, and on an object you can call the equals method, and if you have overridden the equals method for a class, then basically that overridden equals method will get executed, but nonetheless it will get executed because an array is an object in Java. Now this returns true over here in this case. Why? Because of the reference equality. The equals method on arrays does not look at the elements of the array, right? Remember, this would work even on an integer array too, because int is primitive, but integer array is not a primitive thing, it is an object, right? Now the second print statement that is here, which kind of shows a weird output over here, it is even more interesting. Why? What on earth is this kind of output that I'm seeing on the screen? This is kind of baseless, you will think in your mind, but this is not the case. You don't have to know this for the exam, but this L that you see over here, this particular L, it means that it is an array, and then java.lang.string, right? This is the type or the reference type of that array, and this particular thing which I have told earlier is the hash code of this particular object. And if you if you think about it, in an object we have both the equals method and the hash code method. You can override both of them to actually change the behaviors or the default behaviors. I'm not going to talk about the hash code method or the equals method in details in this session because we're going to cover those of things in the future lectures. So let us move on. So what does this thing actually creates is just an array of strings. It will have indexes, and each index will be pointing to a particular value. In this case, the 0th index is cricket, the first index is beetle, and the second index is ladybug, right? Now let us move on. Let us see another example. Let us create another class over here. and let us name this class as names, and let us create a particular variable or it, and let us do this thing. Now what do you think this array points to? There is a string names, right, and it is present in a class as a class variable, right, because that's a instance variable of that particular class names. So in the previous chapter, and basically I think in the chapter 1 we had a discussion on arrays a little bit. So, and we also had a discussion on the default values of the instance variables, and we had learned that the default values of objects is null when it comes to the instance variables. If we do this thing int x, what do you think the default value of x is? It's 0 in this case, because the default value of a primitive integer is 0 in this case. But when it comes to an object, and obviously this is an object, it is null. So this is a very, very tricky question if you think about it, because in this case, even though it is an array, but still we haven't actually assigned something to this array. So basically this thing will be null, right, as an object. Now let us see another example, this kind of example, and let us say class some other names, and in this case let us do this thing. Let us say string names equals to new string, and let us do 2 over here. Now what do you think this particular names array points to? Now we know that this one points to null, and what do you think this one points to in this case? This is an array, right, and basically because it has the brackets, and you would say the same question, right, and you're going to say that okay, this one also had brackets, this one also had brackets, but what's the difference? In this case we are actually explicitly creating an array of strings having the size as 2. So we are assigning something over here, a new string array of size 2. In this case we weren't assigning anything. In this case it's just a normal object, so that's why here in this case it is pointing to null. But here in this case, is it like nothing over here? No, right, because we are actually creating a new array of size 2. In this case it will create an array of size 2, and it will have default values. I think 2 white space values it will have, right? Oh, I'm sorry, 2 null values, because by default string is null. My bad, it was my bad on the part. So it will create, it will create an array, and each of the element in the array will be null and null, right, because the default value of string is null. My bad, I just said it was a empty string, a white space before, but it is a null. So you need to understand the difference between this one and this one, and you can always refer to the basic concepts of instance variables when it comes to this, and you can get everything down, right, and this should make a lot of sense. Alright, let us move on. Now let us talk about casting in arrays, right, and it's a very, very important concept to understand this thing, because you can get confused in this particular scenario. Now remember casting from previous chapters, right, where we wanted to force a bigger type into a smaller type, and it is true in the case of arrays too. You can force a bigger type of reference type in an array to a smaller type. You can do that. It's very easy actually. You can just do this thing. So let us create an array of strings, strings for example equals to, let's say, some value, and in this case let us take Akash, right, only one element is there in this array, and then for example objects equals to strings. Now what is this thing? Okay, we are going to discuss that later on. Let's do this thing, string and let us name this as, for example, again strings, because we are going to convert it back to strings again, equals to string with an array objects. Now what we did over here is we created an array of strings and then we assigned that to an array of object, and there was no compilation error. But because the thing is a string is an object, right? So by this particular implicit casting, an object can hold a string. So that's why an array of objects can hold an array of strings. That is fine. But if we want to convert this array of objects back to a string, we need to explicitly cast it to a string array type. In this case, this one. And remember, you cannot do this thing, and a lot of people make this mistake. This actually doesn't convert it back to an array of strings, but it is actually trying to convert to a string directly, which is not possible. You cannot convert an array to a string, right? So always remember to add a pair of brackets with the data type, right? Let us see another example. If I do again strings of 0 equals to new string builder, this thing, it says it doesn't compile, and it makes sense because obviously this is a string array and you are trying to store a string builder. Doesn't make any sense. Pretty straightforward. Now in this case, objects of 0, if I do this thing, new string builder, but in this case if you see, it doesn't throw any compilation error. But the thing is, you need to be careful about this. Now why do you need to be careful about this? This is where it gets really interesting. From the point of view of the compiler, this is just fine because a string builder object can clearly go into an object array, right? The problem is that we don't actually have an object array, right? Now what does this mean? We have a string array referred from an object array variable, right? Because that's the thing, because this is a string array, and this objects array just refers to that particular string array. It means that that particular array contains strings only, but we are just referring it with a objects array. But the thing is, the values inside that array are actually strings. So what will happen at the runtime? The code throws an array store exception. Why? Let us see this, if I am telling the truth or not. It says array store exception. Why? Because by default a string in Java can hold homogeneous elements. Homogeneous means same type of elements. Even though an object is, a string is an object, so that a string array can refer or point to a string array. Sorry, an object array can point to a string array. That is fine because object is just the parent of a string, because object is the parent of all classes in Java. But the thing is, the actual value inside that array actually matters. Even though it is an object which points to the string, the actual value is actually a string. So in this case, it will not hold any string builder or any kind of other objects. So it doesn't throw a compilation error, but it will throw a runtime error, which is a array store exception. Very important thing to know. Now let us talk about how to use an array, and it is pretty straightforward actually to use the array. And let us see some things about the array. So let us try to deal with this numbers to array. So if I try to do numbers 2.length, then as the name suggests, it will just give you the length of the array, and in this case it should be 3. If you want to get a particular element in the array, just use the index, right? And in this case, if I want to get 50, it is present at index number 1, so I just can do numbers 2 of 1. If I try to run this code, then you can see 3 and 50 over here. Makes sense. Now it is very common to use a loop while reading or writing to an array. Why? Because a loop can iterate over the indexes of the particular array, and you can use the indexes to access the elements in the array or do some operations on the array. So let us see an example. Int something something equals to, we already have the numbers, right? And let us make this 1 instead of 3, let us make it as 10. Let us move on and let us create a for loop, and int I equals to 0, because indexing starts from 0, and then we go from 0 to the length of the particular array, because indexing starts from 0 and goes till the last element of the array, which is the n minus 1th element, right? So we just go I less than equals to numbers dot length minus 1. We can do this thing, or we can just say I less than numbers dot length, and then we can just say I plus plus. And here let us do some stuff. So numbers of I mean at the 0th index, then 1 index, then 2 index, up to the 9th index. So it will be 10 elements in total, right? And in each iteration of the loop we get 1 index, and using that index we will set the value of that particular index in the array. You can just say I plus 5, right? And what will happen? Just the elements, elements in the numbers array will be changed to this thing. And I can use a shortcut to actually display the particular elements in the array. You can use this one. You can use the arrays dot toString function, which will just convert the arrays to a string. And the thing is, why am I using this is just to be a little bit, what it is saying, shortcut, right? Instead of going through the loop again and printing each element, you can just use this function to directly print the elements as a string. So I'm just going to say numbers, and if I run the code, then you can see this is what it is happening. So we are starting from 5, and then with each increasing index we are just adding 5 to it, right? So 5, 6, 7, 8, 9, 10 up to 14. Now the particular exam may try to trick you. How will they try to trick you? They can just include this less than equals to. Now what do you think will happen? In this case, the last index will go till 10 instead of 9. But is there a 10th index in the particular array? No, right? Because 0 to 9, 10 elements. So if you go for the 10th index, it will be 11th element, and that is not the size of the array, right? So in this case, it will throw a index out of bounds exception, because there is no such index in the array, as the array is just of 10 elements. So here we get the index out of bounds element. And remember, this is a very common thing to trick you in the exam. So always look for this array index out of bounds exception in the exam, right? So now let us move on to the next topic, which is known as sorting, right? So Java makes it easy to sort an array by providing a sort method, and I'm not going to discuss any sorting algorithms in data structures and algorithms because it will take up a lot of time. But Java provides you with a bunch of already available sort methods, right? For example, like we use a function in string builder or strings, you can just use the sort method in arrays class. Now the thing is, what kind of sorting techniques that array uses in their sort methods? It is actually not useful to know in the perspective of the exam. You don't need to remember it, but in general, Java uses two types of sorting techniques. One is the Tim sort technique, which is a combination of merge sort plus insertion sort, and this is a stable sorting algorithm that Java uses for reference type. Now just what do you mean by stable sorting algorithm? Basically, if you use a stable sorting algorithm, and merge sort is an example of stable sorting algorithm, other stable sorting algorithms are also there, like bubble sort or something. But what happens is that it preserves the order of elements. If there are, for example, duplicate elements in the array, then it will preserve the order. If the first 5 came before the second 5 as an example, then it will preserve that particular order. So when it comes to reference types, the order actually matters, because you cannot just play around with objects in different orders. If an object comes before another object, then it is important to preserve that order. That is why tim sort is actually used in case of reference types, because we need stability in that case. But when it comes to primitives, order doesn't matter at all, because if there are 3 5s in an array, then we don't care if the third 5 comes before the first one. We don't care about that. In this case, when stability is not required, Java uses the dual pivot quicksort technique. Now, quicksort is a type of a sorting algorithm which does the sorting in order of n log n time. Now, merge sort and quicksort both have order of n log n time, but still in average case quicksort is faster. That is why Java uses dual pivot quicksort, which in where we use 2 pivots instead of 1 pivot, like in a quicksort algorithm. But the thing is, quicksort is not stable, but that is fine because it uses just for primitive types. Now, that is just an overview of the sort method which Java uses. I hope you understood, but it is not required in the case of the exam. You just need to remember that the sort method just sorts an array that you provide to it. So let us see an example, right, how the sort method works. And remember that you need to import the java.util.arrays class to use it, because it is present as a static method in the arrays class. But if you are using an IDE like this, basically it will auto import, like it auto imported in the case of toString method. So it is just very simple to use it. Now let us see an example. So let us create some things like int sort numbers equals to, for example, 6 9 1, and here if I do arrays.sort, just use anything and just pass this particular sort numbers, and if I just say sys out arrays dot toString, and we just pass in the sort numbers array over here, and if I see, then it has been sorted, right? Pretty simple. Now let us see some variations of the sort method. Now if I do instead of sort, so this is one of the variation which it just takes it and sorts it out, all the elements in the array. So if we do arrays.sort, and the parallel sort is just for if you are working in threaded condition, multi-threaded conditions, then parallel sort works for you, right? So arrays.sort, if I do this thing, we just pass in the sort numbers array, and then we start the beginning index like 1, and the ending index we pass, for example, 2. So what it will do is it will just sort the element from the beginning index and the ending index, right? Now if I run the code right now, then just a minute, sorry. So now you can see that it started sorting from the first index, which is 1 over here, so 0 1, and it went till the last index. In this case I have provided 3, so it will go till 2, right? So it went from 0th index and then the first index, and it sorted these 2 elements, right? So this is a variation of the sorting method which is interesting, and you have to provide the starting index and the ending index plus 1, right? Because if you provide 3, then it sorts till 2. So let us see some interesting examples about this sorting thing. So let us create this thing, string array strings1 equals to, because most probably I would have created an array string, so I thought let us create strings1. If I say 10 and 9 and 100, and if I do arrays dot sort, and I will just pass this strings1, strings 1, and let us see what is the output in this case. Okay, actually we have to use the arrays.sort. In this case I'm just going to copy this thing, don't have to type it over and over again, and let us pass this strings 1. Now in this case you see this thing, in this case it was sorted in a lexicographical way, because here they are not numbers, they are strings, and when you sort strings it will be sorted in a lexicographical way. Lexicographical means which character comes before which character. As you know, 9 comes after the 1, right? That is why it was sorted like this: 10, 100 and then 9. So it will be true for all of the strings, any of the strings array that you try to sort using the sort method. So it will be automatically sorted in a lexicographical way. So make sure you remember this, because they may try to trick you in the exam, right? So this is an example of a simple sorting method in Java. Now let us talk about the searching in Java, right? Let us talk about the searching. So when it comes to searching in Java, Java uses the binary search technique, so to search the element in an array. Now what is the binary searching technique? It is just that while using binary search technique, you have to pass in a sorted array, because what happens in binary search technique is that the array is divided into two halves, because we calculate the mid using the low and the high. So we start the low as the first index of the array, 0, and high as the last index of the array, which is n-1, and then we calculate the mid. So according to the element which we are searching, we are either searching in the first half of the mid or the second half of the mid. So Java uses that binary search technique, and as we are searching in the first half of the mid or in the second half of the mid in the binary searching technique, I'm not going to dig deeper into the binary searching technique as a whole, because it will take a lot of time. But the thing is, due to that particular approach in binary searching, where we divide the array in two halves, the array needs to be sorted, right? Otherwise we cannot compare with the mid element, because we do not know in an unsorted array if the element is actually present in the second half or in the first half, because we don't know. So the thing is, array uses the binary searching technique. So there is a method called binary search which will return the index of the element that you are searching. Let us see an example. Int numbers 3. To be safe, let us take 3 in this case. Let us say 2, 4 and 6. Right? Do we already have numbers or something like that? Yes, let's take numbers 4 in this case. Now let us do a arrays. Let us see this thing. Arrays. Oh, it got hanged. Arrays dot binary search, and let us pass in the array which is numbers 4, and the key is basically the element that you are searching, and in this case let us pass in 4. Let us run. We are getting an index of 1 because this is where the the element is present at index number 1. Now what happens if we do this thing and we just say arrays dot binary search, and we pass in an element which is not present in the array, so numbers 4, and then we pass the key as, for example, in this case 8, right? So let us see the output. It says -4, and you would have expected -1 in this case, because obviously if it is not found, it should return -1 or false value. Why is it returning -4? The reason it is returning -4 is that if 8 is to be present in the array, where do you think you will insert 8 in a sorted array like this? You will insert 8 at the last position, which is 0, 1, 2, 3, at the third position or the third index. Now what this binary search method does is that it returns you the value in which it negates the position where it should be present. In this case 3 is the position it should be present. So what it does, it first does, not here, let me just write it down over here. It first does, it is negates the position -3 and then subtracts -1 from it. So in this case we get -4. Now if I do, for example, 1 in this case, what do you think the output will be? -1, right? Because 1 should be introduced or inserted at index number 0. So what it does, it just does -0 -1, in which we will get -1. So that's how this binary search method works when we do not have the element in the array. Let us go back to 9 or 8, something like that. Now what happens if you pass in a unsorted array? That is also one of the techniques that you will say, okay, you may get the question in the exam where an unsorted array passes into the particular binary search method. Yes, it is possible to pass it, but do you think that you will get your expected result? The answer is no, because as it's an unsorted array, if you do binary search on an unsorted array, the result is actually unknown, you can say, right? We don't know what will be the result, because if you pass in an unsorted array, then it is not possible to determine the result, because binary search will not work on that. So there is no way around anything for binary search to work on an unsorted array. You have to first sort it, right? So that's it about searching in Java. Now let us talk about Varargs. Before understanding the theory about Varargs, it is actually better if I show you an example about Varargs. Let us create a method, static void Varargs example, and let us do this thing, int, then I do dot and then I say x or something like that. Now this Varargs, if you know about JavaScript or you are a JavaScript developer, you can compare it with the spread operator. Or a spread operator in JavaScript, what it does is it just takes a particular array and spreads it into number of elements of the array. So you can just kind of get all those elements at once. But it is kind of different, but if you want to compare, you can compare. Now if I do this thing now, if I try to call this method, how should I call it? What kind of arguments should I pass for this to work? So I can just do Varargs example. I can pass 1, 2, 3 into it. And here I can just say this out, x of 0, and then for example x of 1, and then x of 2. So what it does is just it is kind of a replacement for an array, right? You can see 1, 2, 3 over here. It kind of looks similar as an array. Everything works fine. You can also run a loop on that. You can do whatever you do with an array. But the thing is, here it comes just a argument, like a var argument, right? And there are certain rules regarding Varargs, that it should always be one Vararg that you pass into a particular method. It shouldn't be the first element as an argument. Like I cannot do this thing. This is not possible. Your Vararg should always be the last element of the particular parameters, right? You can do int y over here, and then we can do this thing. But you cannot have multiple Varargs over here, like int z, int dot z, something like that. So always remember about these rules about Varargs. If you want to use a Varargs, you should always have a single Vararg as a argument. And if you want to have multiple arguments in your method, you should be that the Vararg should be the last element of your parameters, right? Remember that. This should make things much easier. Now in this case also it is a little bit confusing. You will think that this 1 will go to y and this 2, 3 will go to this Vararg, and you are actually true about it. But if I run this code right now, then there is a array index of out of bounds exception. Why? Because as I've already told you, these 2, 3 will go inside this Varargs, right? So in this case, that array that will be formed, there will be only 2 elements in the X. So if I try to access index number 2, which is the third element, it will throw a array index out of bounds exception. So we can just do this thing, and here we have 2 and 3. Makes sense, right? So this is all about Varargs. Okay. Now let us talk about multi-dimension arrays, right? I hope Varargs are clear in your mind, and if you even have a lot of doubts, it is fine, because in the OCA exam it will not be a bigger topic, right? But I have tried to just rewatch that section on Varargs again and again till you remember about it or till you understand about it. Okay. Now let us create another class for the multi-dimension arrays. Let us create a new class and let us name it as arrays multi, right? Let us take a public static void main and let us discuss about this. So arrays are objects, and of course array components can be objects, and it doesn't take much time rubbing those facts together. It means that can array hold another array? That is interesting, because objects and arrays are a data structure and objects are reference types. Can a data structure hold another object? That's the thing. And in this case, multidimensional arrays are possible, where one array holds another array inside of it, right? An array of arrays, you can just say. So how do you create a multidimensional array in this case? So if you remember, while I was talking about one dimension arrays, we talked that okay, you have to use one pair of square brackets, and in case of multi-dimension arrays, and basically in case of 2-dimension arrays, we use 2 pair of square brackets. If you create a 3-dimension array, then you use 3 pair of square brackets. So examples are like this: int vars1. So here we declare a 2D array. This is also possible. Int vars2. This is also possible, because you can see that we have already talked about that we can keep this brackets after the variable name. If I do int this one and then vars3, this is also is possible, because here we are saying that create a array of this 1D array, right? That's why it is a 2D array, and we can use this brackets like this. So what if I want to create multiple 2D arrays in a single line? We can do this thing: int, then I say vars4 and vars5. In this case, it creates 2 multi-dimension arrays. Sorry, not this thing. Another bracket, I forgot. In this case, it creates 2 variables or 2 two-dimensional arrays, vars4 and vars5. Now let us see this example: int vars6 and vars7. What do you think it will create in this case? In this case, it will first create a 2D array var6 and it will create a 3D array of var7. Just count the number of brackets, it should be easier. So this is 1 bracket, 2 bracket and 3 brackets. So 3 dimension. Here it is 1 bracket and 2 brackets. So this one is 2 dimension. That's it. Right? Should make sense. Now let's see how you can create or initialize a 2D array. So let us create this thing: string rectangle equals to new string 3 and 2. Now the thing is, the result of this statement is what? It's an array rectangle with 3 elements, each of which refers to an array of 2 elements. So it will create an array of 3 elements, and each of those particular indexes will contain an array of 2 elements. Now you can think of the addressable range as what? As 0, 0, we'll start from 0, 0, and it will go till what? It will go till what? I think it will go till 2, 1, right? 0, 1, 2, 2, 1, till 2, 1. Now let us try to understand this thing in a, visual way. Let us understand this thing. You'll understand multidimensional arrays in details. So here we have this thing. We have created, so just understand, like we have created an array of 3 elements. So let us create that. So in this case, an array of 3 elements should look like this, right? 0, 1 and 2. And in each of that particular indexes, there is an element of size 2. It means that an array of size 2. So in this case, the first index will contain an array of size 2. The second index will contain an array of size 2. And the third index will also contain an array of size 2. Now remember that these arrays will also have their own indexes. Let us put some elements into it. 1, 2, 3, 4 and 5, 6. If I want to access this particular element which is 3, how do I access that? Now before accessing this element in this particular array, I need to go to this particular array first. And where is this particular array present in this particular array? It is present at index number 1. So first of all, I have to go to index number 1. And then after reaching this particular array, I need to see for the 3 element, which is this one, and it is present at index number 0. So 1 of 0. So this will be the address of this element 3 in the 2D array. Cool, right? Makes sense. If I want to access 5, this one, then it is present at index number 2 of 0, right? So 2 of 0. Okay. So that's how we access the elements in a 2D array. Now let us see some examples now. Right? Let us see some examples. How do we use a multidimensional array? So let us keep some elements inside of it. Right? We can use the array and we can just deal with it. So the most common operation on a multidimensional array is to loop through it. But before going to that, let us first discuss how you can, initialize an array, multidimensional array directly. So 3 arrays of size 2. So I can just say, we can just say rectangle of 0 equals to, right, the first index I'll just say what is this? Oh, sorry. No, my bad, making a lot of mistakes. Right, so I'm just going to take this and copy it 2 more times. So 1, 2, and let us take it to, let's make some changes, and so a bunch of my friends' names. So if I want to access this particular element, so it is present at index number 1 in this array, and in this particular array it is present at index number 1. So if I do sys out rectangle of 1, then I should be able to reach that element. Let me just run it like this, so you can see. This is how we work with multidimensional arrays. Now let us see how we can loop through this multidimensional array in this case. So how do you think we can do this? We have to use 2 loops in this case. One loop for iterating over the outer array, which is in this case rectangle, and one other loop which will iterate over these inner arrays. So for each index of the outer array 0, 1 and 2, we will iterate over the inner array. Make sense? So the outer array will, outer loop for the outer array will go from 0 to 2, because here the outer array index is 3, right? And for the inner arrays, because each of the inner arrays is of size 2, we are just going to go 0 and 1 for the inner arrays. And we are going to do this 3 times for all of the indexes of the outer array. Let us do that. Let us say for int I equals to 0, I less than, I can do this thing in this case for more dynamic purposes, rectangle dot length. Now what does this thing do is, what does this thing return? It will return the length of the array. Make sense? What is the length of the rectangle array? How many inner arrays does it contain? 3, right? So in this case it will return you 3. So it makes sense. I'm just going to say I less than 3 for the outer loop, and then I plus plus. Now for the inner loop, we have to iterate over the indexes of the inner arrays, and in this case these are the inner arrays. So I can write this code for int j equals to 0, j less than rectangle of 0 dot length, and j plus plus. What is happening over here, you'll ask me. Now we know that each of the inner arrays in this outer array rectangle is of the same size. So if I take just the first array and take its size or the length, because if I do rectangle of 0, I get this array, right, which is right over here. And if I do a dot length on this particular array, I'm going to get 2. That's what I require in this particular inner array. So that works. And in this case, I'm just going to say sys out, and I'm just going to say rectangle of I of j. And to make things interesting, I'm just going to use print over here with a tab space so that it will look like a matrix of names /t. And after printing that particular array, I'm just going to go to the next line. So what will happen after printing Akash Avinash? It will print a new line. It will go to the new line and then print Vicky and Dinesh, and then it will go to a new line and then print Murli and Sarthak. So it will go to a new line after printing each of the inner arrays, right? And if I run the code now, and you can see that this is how it prints, like a matrix. So this is how you work with the inner multi-dimensional arrays. Now if you remember, in some of the previous lectures I had talked about the enhanced for loop. I think in the loop section I had talked about the enhanced for loop or the for each loop, and I have told you that it makes your life simple by iterating over the elements directly instead of iterating over the indexes. Now when you do not need the indexes and you just need to work with the elements of the array, you can use the for each loop. And for more details, please refer to the loops section of the course. Now how does the for each loop works? In simple terms, if you want to know the syntax, it goes like this, right? So the for each loop, let me just remove this thing. So for, and then it goes, okay, I need the black one. For, and then it goes the element, and then it goes the array or the collection, and then whatever you want to do with the element, it's up to you. Now what does this thing mean actually is, so this is a collection, in this case it is an array in this case. So each element of the array in each iteration will be stored in this element. This is just a variable, and then you can do whatever you want with that particular element or variable, right? And you can, it is true for the 1D array and the 2D array. How you use it is actually up to you. Now let us see an example and you will understand. So if I try to use the for each loop on this particular array rectangle, so I'll do like this. So for string element, Now why is this thing? I have told you in this particular syntax that this element is basically a single element of the particular array. In this case, what is a single element of this rectangle array? A single element is just a 1D array, right? So I need to capture that 1D array. So that is why we have used a 1D array in this case. Now this is a 1D array. What is a single element in this 1D array? It is a string, right? Because in this particular 1D array, a single element is just a string. So we have to use another for each loop inside of this for each loop, which will be helping in capturing the elements of this particular array. Makes sense? So I'm just going to say for string inner element colon element, and then I can just copy paste this logic from over here to here, just the print statement, and instead of printing this, I'm just going to say inner element, because we directly have the element instead of using the the indexes. If I run it, then we get the same output, right? So that's how you work with the enhanced for loop or the for each loop with multi-dimensional arrays. And this is at the same time I've also showed you the example of how to work with the enhanced for loop for single dimensional arrays like this. So that's it for the arrays section, guys, and I think this much knowledge on arrays should be enough for you guys to appear for the OCA exam and also for the OCP exam also. And yeah, we are going to meet in our next episode or lecture, and it will be on array lists. So till then, have a nice day and bye bye.